Good morning, everyone. Welcome to our session. I hope that you all are having a wonderful re:Invent, getting a lot of opportunities to learn a network. This is NET205, observing and diagnosing your network with AWS. My name is Sohaib Tahir. I'm a Principal Solutions Architect from AWS Worldwide Public Sector team and my co-presenter.
My name is Riggs Goodman. I'm the Technical Lead for the Networking Partner segment at AWS.
Awesome. So from this session today, you will walk out with a better understanding of network observability, how to think about it, and some of the best practices. We are also going to cover some network monitoring tools, how to use them, and how you can use them to observe your network better. And then finally, we are also going to cover some network troubleshooting tools, some of the best practices, and how to use them to diagnose your network. So hopefully by end of this session, you'll walk away with the framework that you can actually take back and apply to your own network observability and operational needs. So with that being said, I'll first dive deep into the overview of network observability. But before I get there, let's go through what our customers are looking for, what we are hearing from some of you. So we know that a lot of you are designing highly available and scalable networks across multiple accounts, multiple regions, multiple VPCs. They become complex over time, and so as your network observability and troubleshooting. So customers want to simplify that. We are also hearing from our customers that they want the ability to understand the network costs and also identify areas to improve their network architecture and design to optimize those costs. And then we are also hearing from customers that they need better network observability so that they can surface security issues, identify any anomalous traffic patterns, block them, and overall improve their and better govern their network security. And then we are also hearing from customers that they also want to identify anomalous traffic patterns, behaviors that deviate from normal trend, so that they can take proactive action to mitigate those trends. And then finally, customers are also looking for better tools, simplify troubleshooting, network connectivity, and performance issues. So when they do this, this will help reduce the mean time to resolution and also maximize the operational efficiency. So throughout this session, we'll cover a lot of different things, and hopefully we will be able to answer and address some of these challenges that we have been hearing from customers and like yourself. So now we understand what our customer is looking for, so let's try to develop an understanding of network observability. So the way we think about network observability is that network observability gives you the ability to efficiently collect, monitor, and analyze your cloud network. When this is done right, this helps you improve your operational availability. It helps you reduce your mean time to resolution. And it also provides you insights that help you to optimize cost, identify any issues, and also help you improve your overall network design and architecture over time. Network observability also helps you to understand the cost of your operational failures. And then that's why it's very important to think about network observability upfront, especially when you're designing your networks. So what are the different phases of network observability? The first step in network observability is the collect phase. This is the one where we collect metrics and logs, basically the network telemetry data. And this allows you to understand the state of your network, and also provides you the ability to instrument your network performance and connectivity. We often see that customers don't detect the issues as soon as they begin. So your telemetry and your collection should be good enough to help you detect issues as early as possible. Metrics and logs also play a very important role in baselining your traffic patterns. So this is the way you can actually figure out, okay, this is the normal trend of my network, and this is when that trend deviates from the normal baseline, you can alert and you can monitor accordingly. And it's also important to collect your metrics and logs from all the different parts of your system, especially if you're using multi-component system, so that if something goes wrong, you can debug a multi-point failure easily. And then additionally, you can also quickly respond to failures if you are alerting and you're monitoring the right metrics and data. So that's the first phase. The next phase is the monitor phase, in which basically once you have collected the metrics and logs and you have identified the right set of metrics and logs, so you might be collecting more logs and more data, but it's also important to know what to alert on. If you are alerting on too many things, you can create false alarms. If you're not alerting on the right amount of metrics and data, then you can ignore or you can actually miss detecting the issues. So that's very important. So once you collect your logs and metrics, then the next step is to create the alarms, filters, dashboards to monitor them proactively. And we are going to cover some of the ways in which you can do that. But when you do this, this allows you to identify issues, anomalous trends proactively. It helps you to notify relevant teams, sometimes also automatically remediate them. And the final step in the network monitoring is the analyze phase. This is where customers are spending most amount of time during an operational event or during a root cause analysis. This is also the largest contributor to the downtime. So when you have an issue, you're trying to analyze logs, metrics, you will spend a lot of time. So it's important to analyze the right things and have a framework around that. So cutting through all the chaos, all the noise, and focusing on the right thing is a difficult task for a lot of our customers. We constantly hear that. So we are constantly trying to improve this area. That's why we provide you multiple tools that can help you focus on the right information and for diagnosis and reducing your mean time to resolution. So one of the best practices is to also automate your deployments, or when you have found a fix to a problem, to a network operational issue, and when you're trying to deploy the change, it's a best practice to deploy, to test them upfront and then deploy them in production. So if you can automate this process through infrastructure as code best practices, CI/CD best practices, it can help you reduce the configuration errors, human errors, make your configuration more predictable, and overall helps you improve your network design and also improves your network operations. Some of the services that we are going to cover later in this session, such as the Reachability Analyzer, Network Access Analyzer, Transit Gateway Route Analyzer, these are the tools that you can actually use as pre-checks as part of your deployment pipeline. So before you deploy your network configuration production, you can test it out, and when you're confident, then you push it out to the production. It's also best practice to perform post-event analysis for shared learnings, identifying any design flaws, and also to determine how you can prevent from that failure to happen again. And your goal should be to make sure that issue doesn't occur again, but if it does, you can quickly identify it, and then you can proactively remediate it. And some of the tools that we are going to cover, we have kind of put them in 3 different buckets, but some of the tools here kind of cross these boundaries as well, such as the VPC Reachability Analyzer. You can use it for, like I said, as part of your CI/CD deployment models. You can also use it for troubleshooting. So these are not hard boundaries, but this is the way we kind of think about network observability overall. All right, so now we have a better understanding of network observability. Let's dive deeper into the network collection and monitoring. So your AWS network can grow over time and can become very complex, so as your network observability. So let's start with a simple architecture, because the framework that we are going to talk about is going to apply the same way, whether you're starting small, simple architecture, or you're building like a hub and spoke, multi-region transit gateway architecture. So in this architecture, we have a 3-tier web application, a pretty common one. We have an EC2 instance running that application behind an application load balancer, which is a layer 7 load balancer. We have an AWS network firewall, which is inspecting the traffic to and from the internet gateway. And then we have a NAT gateway that allows the private resources, such as the databases in the private subnet, to be able to go out to reach out to the internet and grab the updates and security patches and things like that. So how to go about monitoring this kind of a network? So the first service I would like to talk about, and you might be familiar with this one, is the CloudWatch metrics. AWS provides a lot of the out-of-the-box CloudWatch metrics for many of the AWS networking services, such as the transit gateway, the load balancer, NAT gateway, EC2 instance network attributes, Route 53, and so on. Metric collection is important. It can be time-consuming as well. And you might also want to collect metrics from your application. So if going back to a 3-tier application, we are running the application on EC2. So you might also want to push your metrics from the application side into CloudWatch as well. And you can do that by using CloudWatch agent. You can use the CloudWatch agent to push your custom metrics and also your logs into CloudWatch service. So now you can actually monitor both the AWS services and your custom metrics in the same place. And then once you have the metrics in CloudWatch, particularly for our default services, you can decide the granularity. You can monitor some metrics on 5-minute interval. For some, you can actually go down on down to 1-minute granularity. So you can tweak those things depending on how you want to baseline your application and network, and then how you want to create alarm and monitoring on top of that. So going back to our 3-tier example architecture, monitoring EC2 network attributes, it's key to understanding your overall network performance. We provide EC2 instance metrics such as network in, network out in CloudWatch in terms of bytes. So that's always available. But with the Elastic Network Adapter, ENA driver, we also give you the ability to track when traffic exceeds the network allowances assigned to your Amazon EC2 instance at the instance level, such as the bandwidth capability, the packet per second, the connection tracking limit, the packet per second limit for some of the local proxy services, such as the metadata services, the DNS. So it's also important to monitor these attributes as well. And then when you monitor these metrics, it helps you to troubleshoot instance performance issues, helps you right-size your instance, also helps you to plan your scaling activities proactively, and then it eventually helps you to kind of benchmark your application to determine whether you're maximizing the performance available on the EC2 instance, or you want to maybe go to a different one. So it's very important to also, as you're thinking about monitoring your application, these metrics, take benefit of these metrics as well. So going back to our architecture, we had a load balancer as well. So we also provide you metrics for load balancers. And the kind of metrics available to you are dependent on the type of load balancer you're going to use. So we provide you 3 different kind of load balancers. The first one is the application load balancer, which is basically the layer 7 load balancer. So with ALB, you can actually monitor metrics like the number of connections, the HTTP request count, the HTTP error codes, healthy host count, which is more on the target side, the bytes processed by the load balancer, and so on. Similarly, for network load balancer, which is a layer 4 load balancer, you can monitor the number of active flows. You can, again, monitor the healthy host counts, packet per second rate, TLS metrics, some of the TCP attributes, and so on. And then for gateway load balancer, which is a load balancer that allows you to deploy inspection model. So you can deploy your own third-party firewall appliances behind a gateway load balancer. We also provide you metrics so that you can monitor the health of the load balancer itself, the connections, and also the targets behind it, such as in terms of the number of flows, the total number of healthy targets, process bytes, and so on. So with the application load balancer, we also provide different target types. You can have an EC2 instance as a target, and we also have Lambda as a target. So we also provide some target-specific metrics that you can also leverage. So now you have determined the metrics you want to monitor. You know the AWS services that you are going to monitor, the metrics for those particular services you want to monitor. You're also pushing your own custom metrics in CloudWatch that you want to monitor along with the AWS services. What do you do next? That's where you can use the CloudWatch alarms. So you can create a CloudWatch alarm against any metric or a combination of metrics as well by using math expression. And then once you define a static threshold, whenever your metric crosses that static threshold, you will get an alarm. This is more of a reactive approach when you are actually using a static threshold to define your alarms. And you should have done the baselining of your application, and you should have a very good understanding of what my normal trend is, what my normal behavior is, and when it is kind of deviating from the normal trend, and then you get alarms. And then once you create this alarm, then you can take some custom actions. You can in case of alarm state, you can send a notification to Amazon's simple notification service, which can deliver emails to your network operation team. You can also deliver notification to your Slack channels, things like that. You can also take Amazon EC2 auto scaling action, Amazon EC2 actions as well. And then you can also, once you deliver the notification to SNS, you can actually invoke a Lambda function, which gives you multiple options to remediate the issues. So that's more of a reactive monitoring. We also support CloudWatch anomaly detection against all of these metrics. So instead of configuring alarms based on static thresholds, you can enable CloudWatch anomaly detection for your network metrics. So when you enable anomaly detection, we use a machine learning algorithm behind the scene, which basically generates a range of expected value that basically defines the normal trend of your metric. And then this type of alarm doesn't really have a static threshold. Rather, you can define an alarm based on whether the metric is above the band, below the band, or both. Like I'm showing in the diagram, we are defining the band, and whenever your metric goes outside of that, that's where you can actually alarm and notify or even take some automated action. And then again, you can enable anomaly detection both on your AWS services metrics and also your own custom metrics that you're pushing to CloudWatch as well. So we talked about metrics, but going back to our collect phase, the other part is logs. So it's also important to collect the network logs. And AWS also provides a bunch of different network logs. But going back to our architecture, we have an application load balancer, so you can actually enable the ELB access logs. So ELB access logs capture information about the request that was processed by the ELB in terms of the client IP address, the timestamp it was received. It also provides you the latencies, the request path, the server responses, and so on. And so you can use the ELB access logs to monitor your traffic, to understand your network flows, how they are being processed by the load balancer, and also use them to troubleshoot issues. And then you can push the ELB access logs to S3. For further analysis, you can even create like Athena and query them. Or you can even move them to something like a quick site dashboard to visualize them in a more meaningful way. So our application is running inside a VPC, so you also need to monitor what traffic is going to and from the VPC as well. So that's where you can actually use the flow logs. We support flow logs for both the Amazon VPC and also for Transit Gateway. Transit Gateway flow log is a new feature. So you can actually use both depending on your network architecture. In our example scenario, I'm focusing on the VPC. So when you enable the VPC flow logs, we capture all the network flows that are going towards all the networking interfaces inside that VPC. So the granularity of the VPC flow log can be at the VPC level, subnet level, or interface level, depending on what you really want to monitor. Again, when you enable the VPC flow logs, it actually captures the metadata about the network flows, which are traversing through your VPC or transit gateway. And it can capture information such as IP addresses, source destination IP addresses, port numbers. If your packet is getting encapsulated, you can also capture that as well. Riggs is going to talk about VPC flow logs in more detail, but flow logs can actually help you in a number of ways. It can help you diagnose overly restrictive security group rules. It can help you monitor the traffic that is reaching your instance, and it also helps you determine what is the direction of the traffic if you're troubleshooting an issue. So we talked about the application load balancer or ELB access logs. We talked about VPC flow logs. DNS is also a very important component, even for our 3-tier web application, which is a simple application. So you might want to figure out how the DNS resolution is working inside your application or inside AWS ecosystem. So we provide you 2 different kind of logs on DNS side of things. The Route 53 public DNS query logs, which basically captures information about the public DNS resolution that Route 53 is doing, such as it captures the domain or subdomain that was requested, the DNS record type that was requested. If there wasn't any error, it will capture that error response code and so on. And then the other one is the resolver query logs. So if you're doing hybrid DNS, for example, if you are trying to resolve on-premises DNS inside AWS or vice versa, then you can use Route 53 resolver, and then you can enable the Route 53 resolver query logs to capture how those DNS queries are being resolved by either the AWS side or the on-prem side. And then we provide you the resolver query logs for the inbound resolver, if you're familiar with that. Inbound resolver allows you to basically forward queries from on-prem to AWS to resolve AWS side DNS, and then outbound resolver allows you to resolve queries that are being conditionally forwarded to your on-prem DNS that you want to resolve inside AWS. So you can capture all of these DNS queries as they are traversing through the inbound and the outbound resolver. And then also, we have a .2 resolver or +2 resolver inside the VPC, so the resolver query logs also capture the DNS queries hitting that .2 resolver. And then if you're using the Route 53 DNS firewall, it will also capture that. One thing to note here is both of these logs only capture the unique query. So if DNS also works a lot on the caching, so if your query response is being cached, that is only logged once, not for the cache response. Going back to our example architecture, we also had an AWS network firewall that was inspecting traffic to and from the internet gateway. So we also provide you network flow logs for AWS network firewall. So that also allows you to capture network flow level data for the stateful engine of the network firewall that you might be using to block or allow a certain kind of traffic. And then network firewall also provides you alert logs. So if you are not really blocking traffic, you can generate alerts, and that is also captured as part of the logs. And a lot of these logs can actually be shipped to CloudWatch logs that I'm going to talk about in a bit. Also, Amazon S3 for long-term retention and auditability. And also, Kinesis Data Firehose, which basically allows you to integrate your logs into third-party monitoring tools. So that's also a very important integration if you're using third-party monitoring tools. Okay, so I've been talking about all these different logs, flow logs, ALB logs, AWS network firewall logs, Route 53 logs. You can basically centralize all of these logs into CloudWatch logs so that you can centrally view them, search them, query them, and analyze them. So that's where the CloudWatch log actually comes into picture. And CloudWatch logs now also support cross-account logs. So if you have multi-account structure, you can actually ship all the logs to one account. That can be your logging account. You can actually centralize logs and monitor and analyze them in one place, especially in a multi-account architecture. So once the logs are in the CloudWatch logs, you can actually search them. You can actually query them. CloudWatch provides you its own query language, what we call as CloudWatch logs inside. It's a very powerful query language that you can actually use to write your own queries, custom queries. We also provide you some sample queries for some of our popular logs, such as the VPC flow logs, Route 53 logs. So you can start from the sample queries. You can customize them to your own needs as you're analyzing the logs. And then it also kind of automatically discovers the field. So whatever fields are in the log, it can discover it, and you can actually pinpoint, okay, this is the field I want to analyze further, and you can do that. And you can also plot the logs, and then you can visualize them on kind of a chart in terms of pie chart, bar chart, and all of that kind of stuff as well. So you can take the log data and you can actually convert that into more visualizations if you want to analyze the log data in that way. And then the CloudWatch can actually retain your logs for indefinite. By default, if you're shipping your logs into CloudWatch, your own custom logs, AWS logs, they will be there for indefinite time, but you can change the retention policy from anywhere 10 years down to 1 day based on however you are retaining your logs. A very common pattern is customers will ship their logs into CloudWatch logs for analysis, keep them there for a while, and then ship them into S3 for long-term archival. So that's also a pattern that you can think about and adopt as well. And finally, there's one more thing you can do with CloudWatch logs. If you're shipping your logs to CloudWatch, you can actually also create metric filter on top of your logs. For example, if you're sending your custom application log that has error codes, you can create a specific metric filter for looking for that particular error code, like 504, and it will create the log data into metric data. and then you can actually use the alarm on top of it. You can even use anomaly detection. So okay, I have a trend of 5 or 4 errors, but if it goes really high, it deviates the pattern, then you can actually get alarm on that as well. So that is a way to convert your log data into metric data and then generate alarms on top of it. So we talk about logs in the previous section. A lot of times you want to identify the top talkers or top contributors to your network. This is where you can use the CloudWatch contributor insights. Contributor insights enables you to analyze the log data and create like a time series that displays the contributor data. So this allows you to kind of find the top end talkers that are talking to your application. In our scenario, 3-tier application. You can find the top talkers in terms of IP addresses, in terms of the URLs, in terms of the bad hosts, and so on. And then once you identify the top contributors or the total number of unique contributors, you can actually dive deep into the individual contributor data to understand their usage, whether that usage is normal trend or anomalous trend, and then that allows you to automatically block stuff and take actions. So this is also very important to kind of use as part of your overall network observability, because it actually allows you to figure out how the clients are interacting with your application or with your network inside AWS. And then you can add the contributor insights into a CloudWatch dashboard for centralized monitoring as well. So I talked about a lot of different things: metrics, alarms, logs, and then contributor insights. How to do all of that in one place? That's where you can use CloudWatch dashboard. So CloudWatch dashboard allows you to have a centralized dashboard. It can be a cross-account, cross-region dashboard, where you can add your metrics, your alarms, your logs, your contributor insights in one place. And then you can share them across team. So this becomes your operational playbook. And you can actually proactively monitor your CloudWatch dashboard. And then you can create CloudWatch dashboard in a bunch of different ways. You can create an application-specific dashboard. You can create a network-specific dashboard. Maybe you want to create a dashboard for connectivity within AWS, connectivity to internet, and so on. So a lot of different ways how you can create dashboards, but this allows you to monitor your resources in one place proactively. So if you're not taking benefit of that, this is a pretty powerful tool that you can adopt as part of your network operations and network observability. And this also becomes your playbook. So you can also define certain workflows. You can add more things to your CloudWatch dashboard. For example, if in case of a network event, you can define a playbook that these are the top, these are the 5 steps, or this is the escalation part that you should follow. You can also put that on your CloudWatch dashboard as well. So bringing it all together. So we started with the 3-tier architecture. We talked about a lot of different things, how you can observe your network, you can collect the network telemetry data, how all of this works together. So first of all, you can identify the CloudWatch metrics that you want to monitor that helps you instrument and gauge your application and aligns with your monitoring goals for all of these services, for the network firewall, for application load balancer, for EC2 instances, for NAT gateways. Then you create alarms for these individual metrics so that you can get proactive alerting through, let's say, CloudWatch anomaly detection. And then you add these metrics and alarms to your CloudWatch dashboard. When it comes to logging, you can enable logs for your network firewall, for your application load balancer, for Amazon VPC, and then your DNS through Route 53. You can push your own custom logs from your EC2, or if you're using containers, into CloudWatch logs. And then you can use the CloudWatch contributor insights to identify the top talkers. And you can add all these logs and insights onto your dashboard. So now you have a dashboard for your 3-tier application that allows you to monitor all the aspects of this application so that you can proactively identify issues through a centralized monitoring. So as your footprint starts to grow on AWS, you will start to create more VPCs. You may expand into other AWS regions for DR purposes. You may create a hub and spoke architecture with transit gateway in multiple regions. You might connect multiple transit gateways together, and then through transit gateway peering. You might also be using like a cloud WAN network for global connectivity. So how to go about monitoring this? This is where I would like to talk about AWS Network Manager. The AWS Network Manager allows you to create a single view for your global network and enables you to centrally manage both your Cloud WAN and your transit gateway networks across AWS accounts, regions, and on-premises locations. This week, we also announced some consolidation. So now AWS Network Firewall, AWS Network Manager can also show you VPC Reachability Analyzer. So the feature that used to exist in other places, now we are kind of consolidating all of them under the AWS Network Firewall, AWS Network Manager umbrella as well. So that's a new change that we launched this week. So the Network Manager can actually can provide you CloudWatch metrics. It can even provide you event tracking, topology, logical network diagrams, so you can visually look into your network and figure out if there's any issue, and so on. So Network Manager console provides you a dashboard where you can actually monitor and visualize your global network, including your transit gateway resources, your data center locations, your branch offices, your VPN connections, SD-WAN connections, VPCs, and so on. And then it can give you information about the resources in the global network. You can see the geographical locations. You can visualize that through a network topology. You can find the logical network association between those resources. So this basically dashboard helps you to monitor and view the health of your network in one place, therefore helping you to simplify your day-to-day operations. So if you're not leveraging this feature and you're using Transit Gateway and Cloud WAN, this is a best practice to use the service, as it will help you not only monitor your network, but also help you troubleshoot by some of the capabilities that it delivers. And then it provides a topology graph and topology tree. Both of these can actually help you to quickly identify if there's a issue going on with any of your connections, any of your associations, and then you can go and you can troubleshoot that. The AWS Network Manager also provides you metrics. The CloudWatch metrics I was talking about are directly integrated into AWS Network Manager for services like Cloud WAN and Transit Gateway. So you can easily monitor things like bytes in, bytes out, packets in, packets out. You can create alarms, and you can actually monitor all of that. Instead of using the CloudWatch console, you can actually use the Network Manager console to monitor all of that global network in one place. And we also give you events as part of AWS Network Manager, so you can take automated actions. So if, for example, if your VPN connection goes down, you can fail over to a different one. If your BGP connection goes down, you can get notified and you can take an action. So it generates all the notifications for topology changes, for network changes, for state changes, so that you can either notify the relevant team or you can build like an automation workflow to kind of remediate and take proactive action on those network events. So many customers are also building hybrid connectivity through site-to-site VPN, direct connect to various on-premises locations to support multiple use cases, such as backing up data to the cloud, maybe integrating your on-prem application to AWS-based applications, or maybe just giving private access to your workers to AWS as well. So how to monitor this type of connectivity? So the way you can do that, if you're using site-to-site VPN or direct connect, site-to-site VPN and direct connect both provide you metrics, CloudWatch metrics, about the connection state, the bytes in and out, so that you can monitor those connections. For VPN, you can figure out, we also provide the connection state, so if the VPN connection is going down, you can actually create an alarm and can get notified. For Direct Connect, we provide you connection level metrics, and we also provide you virtual interface level metrics if you're familiar with Direct Connect. So if you're segmenting your traffic based on virtual interfaces is also equal to a VLAN, so it's different virtual interfaces are different VLAN. So if you're segmenting your traffic based on that, you can figure out how much each of the WIF is consuming the bandwidth, so that you know that, okay, for my entire direct connect connection, this WIF is taking this much bandwidth, and the other WIF is taking a different bandwidth, and you can do like traffic shaping, policing based on this kind of insight as well. And then for site-to-site VPN, we also provide you logs that can help you troubleshoot IPsec, IKE, DPT protocol issues by giving you insight into those protocol level data. All right, so you might also be using, let's say, a PrivateLink to connect to third-party SaaS products, or you might be running microservices architecture that you're exposing to other VPC through a PrivateLink. You might also be using gateway load balancer, like I discussed earlier, to do centralized inspection with your own third-party appliances. So how to monitor that? So The way you can do that is we also publish, the AWS PrivateLink service publishes data points to CloudWatch for interface endpoints, gateway load balancer endpoints, and endpoint services. These metrics include new and active connections, byte process, package received and dropped, and so on. PrivateLink also provides you built-in contributor insights for your endpoint services to help you find which endpoints are the largest contributor to each supported metric. So the rules can include ranking endpoints by the number of active and new connections, number of bytes processed, ranking endpoints based on number of TCP resets, and so on. So you can also, if you're using PrivateLink, you can benefit from these metrics and data as well. So we talked about a lot of different things under network monitoring. So what are some of the best practices, or how we can summarize some of this? So the first one is define your monitoring goals. Define your key performance indicators. Not all metrics will be your key performance indicators. So baseline your application network and figure out which metrics you really need to monitor. That's a very critical thing. Once you identify what metrics you want to monitor, you also need to figure out what resources need to be monitored. Monitoring too many resources may hide the real issues or create false alarms. So that's also important consideration to have. It's also a best practice to determine how often you want to monitor the resources. And it can be different for different resources. Maybe for some resources, you want to monitor them on 5-minute interval. For other resources, you want to go down to 1 minute, and so on. Also evaluate what monitoring tools you are going to use. Are you only going to rely on AWS services, such as CloudWatch, AWS Network Manager, so on? Or are you going to use third-party tools as well? And how you can integrate the native AWS tools with those third-party products. It's also important to have a monitoring team. It can be the application team who's basically managing the network, or it can be a separate network operations team or a network performance team who can monitor the resources. And this is important because if you are creating all these dashboards, all these insights, and no one is monitoring it, your issues will go unnoticed, the trends will go unnoticed, and the opportunities to optimize your network design will be there, but will not be materialized. So it's important to have a monitoring team and resources who can monitor your dashboards. So also important to define your escalation path for an event, or in case you have an operational event or a network failure or something like that. It's also best practice to document your investigation process through a playbook. So playbook gives you predefined steps to identify issues so that you can fix a problem by a very well-defined process. For example, if your DNS is not working, what are the steps your network team should take to try to resolve that? And you can also define an escalation part as part of the playbook as well. And then finally, it's important to find opportunities to remediate automatically. Test your changes. So instead of deploying network changes manually, build a deployment model, maybe through a CI/CD pipeline, infrastructure as code best practices, so that you can limit the human errors. You can test your configuration upfront by deploying it to a test environment, and then using tools like VPC Reachability Analyzer, Transit Gateway Route Analyzer, so making sure that when you're deploying that network configuration, there are no surprises. So with that being said, I will hand it over to Riggs to come to walk us through the rest of the session.
Thanks, Hyde. So we talked a lot about network monitoring, the logs, the metrics, the things that you can collect. But network observability is more than just monitoring. It's also analysis. It's also troubleshooting. You just build all your VPCs, the subnets, the route tables, service groups, network ACLs, internet gateways. How do I make sure that I configure that properly? How can I make sure one resource has access to another resource? Customers are calling in saying, hey, I'm not able to connect into your application. You're having latency issues, performance issues. How do you troubleshoot that on AWS to understand exactly what's going on and where it's possibly AWS's network or possibly out on the internet? And then there are certain times where you need to look deeper into what's happening on the network. We mentioned VPC flow logs. We also support traffic mirroring. What can we do with that to do the analysis, to do the troubleshooting, so you can have full visibility into what's going on in AWS? So the first thing that a lot of customers ask us is, I have built these networks. I have built my VPCs, I've built my route tables, I've built all of this stuff. I've interconnected with transit gateways. I want to understand, am I providing the correct connectivity? Did I configure my service group properly? Am I getting blocked from one resource to another? How do we do this instead of just sending ping packets, doing traceroute? What is a better way to do this to make sure that we have connectivity between our resources, across VPCs, across transit gateways? AWS has 3 different services for this. First one is VPC Reachability Analyzer, where you can take a source resource and a destination resource, and being able to understand whether or not you have connectivity in between them. Second one is Transit Gateway Route Analyzer. This one is you have a source attachment, destination attachment, you give it a destination IP, it will tell you whether you have connectivity in between your transit gateways, whether it's a single transit gateway, you're peering in between transit gateways, across the transit gateways and across those route tables. And then the last one is Network Access Analyzer. There are certain times where you don't want to just look at a source resource and destination resource. You want to analyze your entire VPC across your account to understand what has connectivity what, so internet connecting into all your resources going out to the internet to make sure that you configure things properly and you're giving the right security rules, or network ACLs in order to make sure that you're configuring that properly. So let's walk through each one of these. So first one, you have two resources, source instance, destination resource instance. How can I validate whether or not my service groups are configured properly, my route tables, my ACLs, if this is going across the transit gateway? How do I make sure that I have the connectivity there? VPC Reachability Analyzer uses automated reasoning in order to understand exactly how you configured your network. So it goes through and looks at everything. On the screen right here, you have a source resource going to an internet gateway. It is going to show you a path from the source ENI, what service group is going to hit, what network ACL, what route table, and eventually gets to the internet gateway so you can see an overall path. If you are blocking traffic for one reason or another, it's going to show you where it's blocked. One of the things that we announced this year is the ability that's not just showing what service group you're hitting, or not just showing what network ACL, it will give you that line in your network ACL that's blocking the traffic. You can define what port you want, what protocol, what destination IP address, in order to understand from one resource to another resource whether you have that connectivity. One of the things that we announced at reInvent this year is now you can do this cross-account. It used to be all the resources had to be in the same account. Now it is cross-account, so you can have a source resource in one account, destination resource in another account in the same organization, so you can see whether or not you have connectivity there. Same question comes up that I have all these transit gateways. I'm peering my transit gateways. I have a source attachment, destination attachment. How can I validate whether traffic for a certain destination IP address can get through my route tables, get through the transit gateway? We provide a similar type of visualization tool that you'll start at a source attachment, you'll give it a destination IP, and then it will walk you through what route table you're hitting, what is the rule or what is the route table entry that you're hitting, is it going across a peering attachment? You can actually include middle boxes along the way, so if you have centralized inspection, you can say, hey, I'm gonna have a middle box in the way, and you can see the entire path going through. So it gives you the capability to understand from a source attachment to a destination attachment whether you have that connectivity. But there's many times that it's not just about a source resource and a destination resource. You don't want to have to keep going source, destination. You want to be able to analyze your entire VPC, your entire account to understand what connectivity you have. This is where Network Access Analyzer comes into play. There are many times when you create your VPCs, create your accounts, you want to understand whether or not you're doing segmentation properly, whether or not you have accessibility or you're doing paths and other things to make sure that you're providing the correct security. So certain resources that are more internal resources are not accessible over the internet. The way Network Access Analyzer works is you define different scopes. We have 4 different default scopes: internet ingress, egress, and VPC ingress and egress. What these scopes do is they will look across your VPC, starting from an internet gateway to all the resources that you have, or go in egress resources to internet gateway, or if you have attachments or endpoints or other things in your VPC, these are default scopes that you can use to analyze your entire network within a single account. You can also do custom scopes. What this allows you to do is if you want to say, I'm coming from the source subnet or source IP, and I want to see what has accessibility, or I want to put in a TCP port, UDP port, or other things, or limit the types of resources that I want to analyze, you can do that through templates with network access scopes. The output of this is we'll show you every single source and every single destination resource that has connectivity across your VPC. So if you're doing from an internet gateway, it's going to start at the internet gateway. What are the ENIs that I have access to? For certain IP addresses, certain ports, for other things, it analyzes your entire network so you can have visibility into whether you're giving the proper access into your accounts. The one thing that Steve mentioned, we changed what all Network Manager has in it now. It used to just be transit gateways and Cloud WAN. Now we're trying to make a network operations portal that you can use. So VPC Reachability Analyzer, Network Access Analyzer, and Transit Gateway Route Analyzer now all shows up in Network Manager. So you can go into Network Manager today, look in console, you'll see all these tools that you can use to understand exactly what type of connectivity you have, what your transit gateway is doing, what Cloud WAN is doing, as a centralized place to see visibility into your network. All right, I have to poll the audience right now. How many people are network engineers? Finish the sentence for me. It's not an application problem, it's a network problem. Always the same comment. One of my customers had an issue one time where customers started calling in having an application issue. The network team was being told by the application team, you're having a network issue. They started troubleshooting. It took 3 days for them to prove that it wasn't a network issue. Okay? Because they had to turn up new instances, show this, show that. Ended up being an application issue. But one of the things they came to us saying, hey, how do we simplify this so we can see whether we're having performance issues on AWS and even whether the internet is having an issue. There are many times where service providers or things connecting into AWS is having an issue that impacts users coming into AWS to connect to your internet-facing applications. At reInvent this year, we released 2 new features. First one is infrastructure performance. This is also one that shows up in Network Manager. Many times, customers want to know what is the latency intra-AZ, inter-AZ, and inter-region. Now, AWS provides you the P50 average numbers to you that you can see exactly if there's a network event happening on AWS. You can send it to CloudWatch. You can create alarms with this. And so you can define what you want to see. Intra-AZ is going to give you the P50 between all the different availability zones that you select. Inter-AZ, same thing across availability zones. And you can understand that when users start calling in saying, hey, I'm having an issue, whether or not AWS is having a network event. And then also, if you have an application in one region, you want to expand to another region, but you need certain latency requirements, you can look at the numbers that is given to you with infrastructure performance to understand whether it's going to meet your requirements going from one region to another. The other question is, and Dave Brown kind of said this in his keynote earlier Wednesday, is there are many times where there are issues that happen out on the internet. He called it bad weather, where service providers are having some issue. Users are now saying your application is having an issue. It's not a service provider, it's an application issue. AWS released CloudWatch Internet Monitor. What this does is AWS collects a lot of data from the internet, whether it's users connecting into your applications, users connecting to other applications, and we're able to build Internet Monitor to give you availability score and performance score of customers connecting into your application, okay? This can be VPC, this can be CloudFront, and this can be workspaces, and we give you those 2 scores, including things like first byte latency, round trip times, and other things, and we use statistical analysis to identify whether or not service autonomous system numbers are having issues. If you have one autonomous system number that the average latency that you expect is 100 milliseconds for users connecting into Las Vegas, and that jumps to 200 milliseconds, we're able to identify that and give you, instead of having a 100% performance score, maybe that drops down to 95, maybe that drops down to 90, so you can understand when customers start coming in whether or not there is something happening on the internet with customers connecting to your application. So let's dive into this one a little bit more. So I mentioned performance scores and availability scores. When nothing is happening on the internet, your performance score is going to be 100%, availability score is going to be 100%. you can filter by different autonomous system numbers and locations to see whether certain locations or certain autonomous system numbers are having issues. Your performance score is going to drop if statistically, with all the data that we have on historical averages, the availability and the performance drops outside a certain range. So it can go from 100%, 90%, 80%, whatever it ends up being, of the number of users that are affected by that event. You can push these to CloudWatch. You can do alerts on them. So for your internet-facing applications, you can see exactly what's going on when users connect into your application. I just had a screw fall out of this, okay. The other thing that we do, we're able to do maps. So if anybody understands BGP and internet route tables, public IP addresses, there's a good chance that you can identify where certain public IP addresses are coming from. Whether it's Las Vegas, London, Singapore, you can identify exactly where that's coming from. So we can say, in Las Vegas, connecting into your application, we're seeing the performance drop, or we're seeing the availability drop, and you're able to view it on a map. You're able to understand exactly how long this event has been happening, the number of users, the percentage of users that are affected by this, and what type of event it is, to understand how users are connecting to your applications, and whether or not it's an internet-facing issue compared to an application or a network issue on AWS. This is in preview right now, availability in console today. It's a really cool tool of how we use data and use statistical analysis and automated reasoning to understand exactly what's happening on the network. All right, the last thing with troubleshooting. There are many times where you're having an issue and you need to look deeper into what's happening on AWS. This could be, you need to look at the flows, or you need to do full packet captures of something going into an ENI and getting a capture of that to send it to your instance or to some type of appliance. We mentioned earlier VPC flow logs in order to get metadata of exactly the flows going across your VPC or transit gateway, and also traffic mirroring of being able to copy packets from your ENI and send it to some destination. With VPC flow logs, we can do it by entire VPC, a subnet, or an ENI, and we can send that to Amazon CloudWatch, Amazon S3, or one thing that we announced this year, Kinesis Data Firehose, then you can send it to a third-party application or to other analysis that you have in order to understand exactly what flows are going across your network. Each flow can have a lot of data in it. We have default versions of the flow, or you can do custom version of the flow. Things like 5-tuple, source destination IP, source destination port, protocol, the number of bytes transferred, whether it was accepted or denied. There's a lot of data that you can get with the flows that you can use and look at yourself, or there's a lot of third-party tools, SIEM and observability tools from partners that gives greater analysis of exactly the flows on your network. So if you have an instance that has 1 meg that always goes to it, and then you're seeing it jump to 10 meg, why is that happening? You're able to understand what flows are coming into that instance. It might just be your application is doing better, and so now you have more traffic coming into it. Or it could be someone turns something up that's not supposed to be talking to that instance, and you can see those flows coming in there. The other thing that we announced this year is transit gateway flow logs. So just like you can with a VPC of get flow logs from different ENIs, now you can do flow logs for both transit gateway attachments and transit gateways to understand the flows that are going across the transit gateway. So you can get full visibility of this is what's happening on the VPC, this is what's happening on the transit gateway, and then another VPC seeing that full flow. These can be sent to CloudWatch and S3 today, and then whether you want to look in there or use third-party tools, you can do that. With traffic mirroring, this is copying an entire packet and sending it to some destination. The way this happens is we take a copy of that packet, and then we put a VXLAN header on it, and you can send it to an ENI, a network load balancer, or one of the things that we launched this year, a gateway load balancer endpoint. So with a gateway load balancer endpoint, one of the things that customers like about this is normally with an ENI or a network load balancer, if you want to do anything centralized inspection, you have a VPC just for your appliances to look exactly what's happening on the network with all the captured packets. You have to route that through a transit gateway. You have to route that through VPC peering or something else. With gateway load balancer endpoint as a target, what it allows you to do is drop different gateway load balancer endpoints in distributed VPCs. And just like gateway load balancer works with firewalls, it's able to send that traffic to the centralized gateway load balancer, and then it sends it to the appliances. So you don't have to worry about the routing getting from one VPC to another. It does it for you by putting endpoints in each one of the VPCs, depending if you want to do distributed or if you want to do centralized. So we talked about a lot of stuff. We talked about metrics. We talked about logs. We talked about analysis, capturing packets, performance issues happening on AWS, out on the internet. AWS is trying to give customers the tools that you can use in order to understand what's happening on the network, troubleshoot what's happening on the network, and give you visibility, alarming, and other capabilities in order to make sure that the applications that you're building on AWS are meeting your customers' requirements, security requirements, and the overall requirements that you have building on AWS. Both Sahib and my email is on the screen. Please, please, please fill out your surveys. It's very important to AWS. It's very important to us. Thank you very much. Sahib and I will be at the back of the room if you want to talk after the show.